Okay, this is our last section for this first class. We're going to have a short discussion about the blood supply to the brain. I'll tell you in a second why that's important. And then we're going to see a clip, a film. Takes about 6 or 7 minutes. And that will be the end of our first class. So hopefully this worked out for you, and we'll talk. Okay, so let's talk about the blood supply. And the blood supply is critical because the blood supply, A, is what nourishes and allows the brain to function, as is true for the rest of the body. All parts of the body need blood supply. But it's disruption of the blood flow to the brain, specifically to the cortex, that causes aphasia if particular parts of the brain are denied proper nutrition as delivered by the blood. Okay. I guess the important anatomy we have to understand about the blood supply, that again I'm sure you learned in high school bio, has to do with arteries and veins and capillaries. And that is the fact that the arteries are the larger and stronger of the blood vessels that emanate starting from the heart, where blood is pumped through the arteries and delivered to all parts of the body, and then they're returned from there, depleted all the nutrients that have been sent. So now the blood has kind of been stripped of everything that is important within it, and it's sent back to the heart through the veins. So we have an arterial system and we have a venous system. The capillaries are the very end of the arterial system, and they're the very smallest, and they're multiply in millions of tiny little blood vessels that reach to every single part of the body. So it's very rare that you would be able to puncture any part of the body and not extract some kind of blood. Except, of course, when they want to get blood from you, to take a blood test, and then it never does work, does it? Okay. This is not a great diagram, but we'll have some better ones soon. But what I wanted to show you here is that this is the ascending aorta. The aorta is the first of the arteries that comes from the heart. It's the largest. And it branches off into smaller arteries. And in this case, what we see is the vertebral artery, which goes towards the back of the brain, the subclavian artery, which goes to other parts of the head. And then that comes to the carotid arteries, the common, and then external, and then the internal. So each one, and what you see is that each one, first of all, it keeps branching. You're not seeing all the branches, frankly. And each one gets smaller. And we call this a process of arborization. Arbor is A-R-B-O-R. It's a word that if you've studied forestry or trees, you might know that because it relates to that. Let's use the tree as a prime example. A tree begins with a trunk, and the trunk is by far the largest and most solid and widest in diameter of all the wooden aspects that grow from the ground in a tree. But a tree doesn't just have one branch or one trunk. A tree typically subdivides into what we call branches. So let's take, for example, now that a trunk grows to whatever height it might grow, depending on what kind of tree it is and how well it's nourished. And then it branches. Let's say that it branches into 5 different branches. So now we've got 5 branches from that one trunk. But each of those branches is smaller than the trunk was. It's not 1/5 of. It's not exact mathematical formula, but it's definitely smaller. And let's assume now that this is just being very geometric, although trees are not, and that each of those 5 branches branched into 5 different branches. So now on this third level, you would have 25 branches, plus the 5 that are below that, plus the one trunk. And what we note is that, A, we have many more, and that each of them is smaller. At each level, it gets smaller. And that's each of these 25 now goes, each one gets 5 more. Okay, so now we'd have what? We've got 125 branches, plus the 25, plus the 5, plus the 1. And again, each one is smaller. Until, if you look at a typical tree, at least trees in North America, at the very top of it, what do you see? You see tiny little branches that we call twigs, right? They're still productive, and they're fine, okay? But it keeps getting smaller and smaller and smaller, okay? And that's the way the arterial system works as well. Those twigs, and a model that we've talked about would be the capillaries. Okay, that's the very end of the arterial system. We have many, many, many more of them than we had arteries originally, for sure, and they're tiny. Okay. The most important artery for purposes of aphasia is usually the middle cerebral artery. And I'll show you some diagrams in a few minutes. You'll see, because the middle cerebral artery is the artery that is responsible for delivering proper nutrition to the major parts of the brain that serve speech and language. Okay? The area that's called the perisylvian area, which is the area that surrounds where the juncture of the frontal lobe, the temporal lobe, and the parietal lobe. And included in there, we have those areas that we've referred to as Broca's area and Wernicke's area. Okay, so what we have here is the anterior cerebral artery feeds this rim where we don't have significant functioning of speech and language. We may have some, we'll see, but not a lot. The posterior cerebral artery does this rim here, and again, we don't have a lot of speech and language there, but again, it's not like we don't know it. But the middle cerebral, that what he said before is the most important, feeds this area. And that's going to include all of the serious, really critical areas of the brain that deal with speech and language. Okay, if we go back to this concept of arborization, okay, and what we're not seeing here is the branches off the middle cerebral artery, is that let's assume that we have some kind of a disturbance of circulation right over here. Well, then everything here doesn't get blood. And that all of that is going to be damaged. So that would be low down in the distribution of the middle cerebral artery. But what if the occlusion or what if the damage doesn't take place until here? Well, then it's only stuff that's above here. So all this might be spared. This is okay. And so when we talk about a patient who's had a stroke and he's had damage, occlusion, something to the middle cerebral artery, the question will always be, where in the middle cerebral artery? Because the lower down it is, the more widespread the damage is, and the more profound and global the aphasia is going to be. Okay, if it's higher up, it's not without importance, but it's going to have less of an impact. This is showing very much the same thing without the arteries themselves. We're just seeing like the left hemisphere, and what you're seeing here is the area that is fed by the anterior cerebral artery, the posterior cerebral artery, and then the middle cerebral artery. These are called watershed regions of the cortex, these areas that are on the rim, that are on the outside. Okay. This tape that I'm showing you right now is going to stop, and you're going to have another one then that is going to have this film, but that's going to be a separate tape. So this will end, and you'll have to log in one more time just to click on this. Take care.